Okay, question number 4. Nikita conducts an experiment to measure how the temperature of drinks can be lowered by adding ice to a cooler box. She repeats the experiment for different masses of ice. The drinks are initially at 22 degrees, and she records the final temperature of the drinks when all of the ice has melted. So if she has added 0.5 kilograms, the final temperature is 15.5, all the way down to 2 kilograms where it is at 2.5. So this data is then put onto a graph. An ideal temperature for cold drinks is 4 degrees. Use the model to estimate the minimum mass of ice required. So 4 degrees is just below here. So if the pen works, come on pen, there we go. Go across there, a bit wobbly, just before that bit there. Into there, so we've got 1.5, 1.6, 1.7, 1.8. I'm going with 1.85, and of course the mark scheme will have a little range for you to figure that out. Okay, so part B, Nikita states that increasing the mass of ice cream from 0.2 to 0.3 has more of an effect than increasing the mass of ice. I said ice cream, didn't I? Ice from 2 kilograms to 2.1. Is Nikita correct? So 0.2 to 0.3, going back to the graph, we've got 0.2 is here. We've got 0.3 there. So we've got quite a steep gradient. And actually, if I was to just get rid of that now, I know that it's here and here. So I'm reading off 19 and 18. So between 0.2 and 0.3 is 1 degree dropped. And then 2 to 2.1. Let's go to 2 to 2.1. That is 1, 2, 3. 2.1 is about 2.75. So 3 and 2.75. 3 take away 2.75 is 0.25, is a drop of 0.25, and therefore we agree with Nikita. There we go. That's quite a bit of work for 1 mark. Quite a bit. Oh, to be fair, it says you don't have to work out the rate of change. So I guess what you could say is there is a steeper gradient at that earlier stage of the graph. The model can also be represented by this equation. Using the measurements from Nikita's experiment, work out the values of B and C. So C is going to be where the graph crosses that y-axis. So where does it cross the y-axis? At 22. So C is 22. And then I want to give you a nice effective way of working this one out. Let's find a value. Let's find a value on the graph. So when the mass is 2, the temperature is 3. So when m equals 2, t equals 3, and we'll work it out from there. So t, which is 3, equals 1.862 squared plus 2b, and then that is plus 22 because we've got that bit out. 3 equals, let me get my trusty calculator out, 1.86 times by 4, 7.44 plus 2b plus 22. Plus 22 is 3 equals 29.44 plus 2b, and then 2b. So 3 take away 29.44 is negative 26.44. And I'm happy with that. I mean, I've got an earlier answer of take away 26.94. And because we're reading off this graph, we're going to have some variation with our answers. So negative 26.44, and then C is 22. C is 22 is going to be that regular answer. And if I were you, I would check that mark scheme to ensure that you're within that range. Describe one limitation of this model. So it's not valid for m being greater than 2.5 because the model predicts the temperature will increase. And that doesn't make sense because adding ice isn't going to make the temperature increase, because if we carry on this graph, it will go like that. And that won't happen. Right, team, that's question 4 done, and I'll see you at question 5.